Hello everyone, welcome to the next lecture on the CSIR NET Math July 2024. In this lecture, I will explain you the part B related question on the linear algebra. I will explain you all these questions with the help of the shortcut tricks. Myself, Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of CSR UGC NET. In this playlist, you can see I have uploaded the 2 lectures on the complex and real analysis solutions. Apart from them, there are many more lectures available in this playlist. All I have explained with the help of shortcut tricks. You must subscribe my YouTube channel so that when I uploaded my next video, you can get the notification. Always remember student, I always tell you in my last videos that you have to read the statement very carefully. Once you understand the statement, then you will get your answer in the 10-second time period. How? You can see if you read the statement, the first word is the quadratic form. Which things come in your mind when the question is related to the quadratic form? That means whether it's a positive definite, whether it's a negative definite, or whether it's an indefinite. That means this question can be solvable by this manner, such that ABC are the tuples and f of ABC are 0. Can you find the relation between the 0 in the quadratic form? That means what is the relation of the 0? 0 means that is either the semi-definite or the function is indefinite. Fine. So that means which of the following case will be at least one 0 will be satisfied. So your target is to check which of the following quadratic forms are my semi-definite or indefinite. So can I write the quadratic form corresponding to the first pair? 1, 2, 3. Rest values are my 0. Now clearly say the eigenvalues are my 1, 2 and 3. All are my positive. Once all are my positive, that means it is my positive definite, but we need a semi-definite. Semi means at least one eigenvalue must be 0. So this option is cancelled. Second method, you can find the principal minor. First principal minor is 1 which is greater than 0. Second principal minor is 2 greater than 0. Third principal minor 6. All are my greater than 0. That means this is the positive definite, but we need a semi-definite. The first option is cancelled. Look at the second value. If I write the matrix corresponding to this 1, 2, 3, this is the minus xy. So this is the x, this is the y, and the rest of the values are my 0. So if you are able to find the eigenvalue, then you can do. But I think it's very simple if you find the principal minor. The first principal minor is 1 which is greater than 0. Second principal minor is 2 minus 1 which is again greater than 0. Third principal minor is 6 minus 0 plus 1 minus 3 minus 0. That will be 6 minus 3 again greater than 0. That means it is my positive definite. So this option is also cancelled. Look at the third option. Can you write the matrix corresponding to this? 1, 2, 3. This is my minus 1, minus 1, y and z, minus 1, z. Again, you are unable to easily find the eigenvalues. So I can use the principal minor. First value is 1, greater than 0. Second principal minor is 2 minus 1, greater than 0. Third principal minor is 6 minus 1 plus 1 of minus 3. 5 minus 3, 2 which is greater than 0. All are my greater than 0, that is a positive definite. So this option is also cancelled. Only left option D is my right answer. How? We can see I can write this matrix as 1, 2, minus 3. Rest values are my 0. Now clearly say the eigenvalues are 1, 2 and minus 3. Some of the eigenvalues are my positive. Some of the eigenvalues are negative. What does it mean? This is my indefinite. Once this is indefinite, so we can get a value of the ABC which is 0. Second method, you can find the principal minors. 1 which is greater than 0, 2 greater than 0, minus 6 less than 0. That means that matrix is neither the positive definite nor the negative definite. That's the indefinite. So definitely we can get a number say 1, 1, 1. Clearly say ABC 1, 1, 1 and this number will be 0. So the right answer is D is my correct answer. Fine. So if you want how you can solve these questions, more practice on the quadratic form, I must recommend you must watch about my these lectures and you can learn various shortcut tricks as well. Second question. If A is a non-zero linear transformation, which of the following is 1, 1, on 2 and so on? What is the shortcut tricks? As I mentioned you in my previous lectures, if F is the mapping from A to B, fine. Then if F is my 1, 1, then cardinality of A must be less than equal to cardinality of B. If F is my onto, then cardinality of A must be greater than equal to cardinality of B. If F is my bijective, then cardinality of A is equal to cardinality of B. And make sure, students, the converse may not be true. Fine. You can watch my these lectures in order to understand more about this concept. Now, based on this simple shortcut trick that I explain you, I can solve this problem in a simple manner. What is that mapping? This is my R raised to power M to R of N. What is the cardinality of R of M? Which is M. Cardinality of R of N is N. In your examination, you don't need to write all these things. You can think in your mind as well. Now, if A is 1, 1, what does it mean? If A is 1, 1, that means cardinality of A, that is M, is less than or equal to the N. But they are talking about M is greater than equal to N. So definitely the first option is straightforward, cancel. Moreover, not onto. Fine, so first option is cancelled. Look at the second option. A is my onto. That means cardinality of A is greater than or equal to cardinality of B. But he said M is less than N. So this option is also cancelled. C, A is bijective. Cardinality of M and cardinality of N are same. So yes, this option is the correct option. D option. A is 1, 1. Cardinality of M is less than equal to cardinality of N. But they are talking only as the equality. Make sure you all knows if you have the mapping from V to V. Fine, that is the same domain. Then this mapping is 1, 1 if and only if this is onto. That means bijective. But you can see this is M is equal to N only when the case of the bijective. But it's a 1, 1. Is it onto? May or may not be, because the dimensions or both are not same. So that means this is not always true. Fine. So the right option is only C is my correct answer. Another way you can think about that, look at that. A is my 1, 1. That means this condition satisfied. A is not onto. Not onto means that is a not bijective. If not bijective means M is not equal to N. Now based on these two conditions, what you conclude? M is strictly less than of the N. So that means this option is, if this option is written in the upside, then it's the correct option. Similarly, if you look about the second, A is onto, that means this condition hold, is not 1, 1. If it is not 1, 1, that means it is not bijective. If it is not bijective, that means M is not equal to N. If M is not equal to N, that means M must be greater than of the, strictly greater than N. But he said M is less than N. But there is no need to think about the others, because I can simply discard the options straightforward based on this shortcut tricks. Don't forget to like and comment on my video as well. Now, look at this another one. A is a 10 cross 10 real matrix. What I told you in my each video, whenever you have a matrix, you can always solve the problem with the help of the rank and with the help of the eigenvalue. Always. Fine. Always remember, whatever the problem is there, you can solve this problem with the rank or eigenvalue. Now what is given to you? Rank of the matrix is 7. Fine. A must have a non-zero eigenvalue. First of all, what is the cases for the 7 rank 7? That means the 3 rows are completely zeros. Fine, because its rank is exactly 7. Now what will happen of this? If I choose this value 0, 0, 1 and so on, that means if I choose a nilpotent matrix, fine, If I choose a nilpotent matrix of rank 7, that means 0, 1, 0, 0, 0, 0, 1, 0, 0, and so on, and the last 3 rows are my 0. All these eigenvalues are my 0. A must have a non-zero eigenvalue. A must have a non-zero eigenvalue. But if you consider these examples, A has all eigenvalues 0. So this option is cancelled. Always remember your target is to discard the option. Any other possible way? Another way is how you can take an as a, if I consider the identity matrix of 7 cross 7 and the rest values are my 0. Fine. Then what will be my A raised to power 7? Again it's the I 0 0 0 and clearly say which is my non-zero. This option is cancelled. Fine. Now look at the first and the second option. There exists, they are not talking about the for all. There exists such that AV is my 0 or AV is my non-zero. So there exists a V. I can assume the vector V is my 1 0 0 0. Fine. Then what will happen? Now clearly say from this case, what is my A square? A square is my A. Fine. Now what will happen of the AV? If I choose this is A, this is V, then definitely it will be my 1 0 0. Fine. It's a column vector. It's a 0 0 and it is my non-zero. This condition satisfied. But what about the A square V? Since A square is again A and it will be my 1 0 0 0, which is non-zero, but he said 0. So I got as a one counter example. So there exists a V which is my cancel out. So right option is only B is the left behind is the right answer of this problem. Also you can see because your A matrix is my 7 cross 7 0 0 0, you can choose any of the vector V which is of the 7 cross 1 and the rest elements are 0, and this V is my non-zero. Fine, that I taken as a 1, or you may taken all as a 1 1 1. So definitely if you multiply them, your answer will be a non-zero, and this, that is a 1 is eigenvalue. So definitely is a non-zero, but A square V, A square is equal to A, so that's why A option is cancelled. B is the right answer of this problem. If you want to find more concepts on the rank, as I told you, you must watch about my the rank and the eigenvalues problem. You can understand this question in a very simple manner. If you are interested to join with me, you can like, share and comment on this. And if you are interested, I will share with you my WhatsApp group as well. Okay, consider the symmetric bilinear form given that V comma W is V transpose A. Very simple, very simple. Which things come in your mind when you look about this case? Quadratic form. Fine. So once is a quadratic form, that means your target is to check the positive definite, negative definite or indefinite. Fine. Now let's see how you can check about that. The matrix is given to me as 0 1 0 0, 1 0 0 0, 0 0 1 1, 0 0 1 1. First of all, clearly say the two columns are same. So that means the determinant of A will be 0. So A is invertible, that's not possible. Fine. Anyhow, how you can check about that? Clearly say I can find the eigenvalues. Fine. So this is the eigenvalues of this. How you can find the eigenvalues? Eigenvalues of this. As I told you, what is the shortcut tricks for you? If it is A, this is B. What are the eigenvalues? Eigenvalues are plus minus A into B. So what is the eigenvalues of this? Plus minus 1. What is the eigenvalue of the 1 1 0 0? 2 comma 0, because it's the row sum is same, that's the 2 and other elements are my 0. So can you find the eigenvalues of this? So I can write for you here. Eigenvalues are 1, eigenvalues are minus 1, eigenvalues 2, eigenvalue is my 0. Fine. So clearly say because one of the eigenvalues is 0, determinant is my 0, so therefore it is not inverted. Every eigenvalue of the A square, can you find the eigenvalue of the A square? Eigenvalue of the A square is 1 1 4, 0. Every eigenvalue is my positive, but you can see 0 is also be there. So this option is also cancelled. Fine. Now I can put up here. Now there exists a non-zero vector u, v and w such that this value will be 0. Fine. When it will be 0, as I told you, either it is a semi-definite or it is indefinite, and you can see these are the eigenvalues, and some of the eigenvalues are my negative, some of the eigenvalues are positive. That means this matrix is my indefinite. Once this is the indefinite, definitely this value will be 0 is the correct option. Now look at the last option, that is the third option. Inner product u comma v is not equal to u comma w for all the non-zero vectors with, remember, whenever you can choose these numbers. Okay, I think again very simple, because you can think about this statement. First of all, u is a fixed value. I can fix the value of the u. The easiest way, I can pick the number as this one. Fine. Now what is the definition is, so I can take on, this is 1, 0, 0, 0. This is my u, and this is my number, say x1, x2, x3, x4. Now if you write in the quadratic form, what will happen? This is my only x2, because 1 into x1 0, 1 into x2, and rest of the elements are my 0. That means my this form u comma x is nothing but my only x2. Fine. Now I think now that's over. I can choose any element of the v, say 1, 1, 1, 1. W I can, because the second element is common, I can choose it as a 0, 1, 2, 3. What is the inner product of u comma v? What is the inner product of the u comma w? Now since u is my this, v is my 1, 1, 1. So element is my only second element. That is my 1. This element is also 1. So both. Now and clearly say v is not equal to w, but they are my equal. But he said not equal. So this option is cancelled. Only right option is B is my correct. Always remember students, whenever you are talking about this form, what does it mean? This is the quadratic form. Once the quadratic form, how you can think about that? Positive definite, negative definite, and the indefinite. Moreover, the matrix is given to you, you can think about the rank or the eigenvalue. If you are interested to join with me, you can scan and join my WhatsApp group by using this code. Okay, look at this another one. Again, you can see the matrix is given to you. Fine. So you can solve this problem either with the help of the rank or with the help of the eigenvalue. What is given to you? The matrix is 2, B, A, C, in which 6 is the eigenvalue. Fine. Which of the following is necessary true? Very simple. Firstly, how the 6 is the eigenvalue? If I choose this number, fine. Is it okay? Then eigenvalues are my 2 and 6. Now look at the option. A plus B is equal to 8. Is it satisfied? A plus B, 0 plus 0, 8 cancel out. A into B, 0, that's fine. 24 minus 0 is equal to 24. Make sure this is a one counter example. You can't correct the option. Now, by using this, we can discard the second option. Now, 6 is one of the eigenvalue. Fine. As I already mentioned you in my this PY question of the eigenvalue, how you can check about the eigenvalues? If the sum row, each sum row is my 6, I can put this number also. You can see the sum of the each row is my 6. So therefore, one eigenvalue is my 6. 6 is the one eigenvalue. Can you find the second eigenvalue? Clearly say the sum will be my 4. Second eigenvalue will be my minus 2. Now clearly say C is equal to 6 is my cancel. AB is equal to 0. Again this option is cancelled out. Fine. So what is the right answer of this? Now you can see whether this option is satisfied or not. 24 minus AB, is it equal to 4 into C? Yes, you can see they are again satisfied. The only left option is A is my right answer of this problem. Fine. This is the first method. Second, which generally the student will do, like 6 is one of the eigenvalue and this will be my trace. Fine. And what will be my determinant is, this is my determinant. So I can write the equation of lambda square minus 2 plus 6 plus of the determinant. And since 6 is the one of the eigenvalue, so therefore I can substitute the 6 value. So 12 minus 6c plus, and again you can see from this case 24 minus AB is equal to 4c is my right answer of the problem. Again, recommended you can watch my PY question of eigenvalue. Student, always remember, your target is not to get the right answer. Your target is to how you can approach the solutions in your examination or before the examination. Okay, look at this another one. V is the real vector space of the 2 cross 2. So that is V is my basically M2. Then V from the V. What is the dimension of this V? Is my 4. So therefore, whatever the matrix T, what will be the dimension of this? It is also 4. So this is my 4 cross 4. Therefore, the characteristics polynomial is of degree 4. So first option is directly cancel out. Rest all are. Now, my matrix definition is given to be as a AB. Firstly, I will tell you the shortcut tricks. How I can define the shortcut tricks? Because the same question I have already explained you in these two lectures. Fine. Because now this is the matrix is given to you, you can solve this question with the help of eigenvalue as well. First of all, if your matrix is given as A, B, 0, 0, what are the eigenvalues? Eigenvalues are A and B. Moreover, this matrix is my diagonal matrix. Fine. Then you can define the transformation of AB as, this is A into identity matrix 0, that is the eigenvalue. Second eigenvalue is B into identity matrix. Now what is the size of this identity matrix? The size of this identity matrix is the dimension of, so 2 cross 2, 2 cross 2. Fine. Now can you write the directly straightforward the matrix of this? What is the answer of this? A is my 2. So it's a 2, 0, 0, 2. It's a 2i. It is my 0, 0. B is my 1. So 1, 0, 0, 1. Fine. Now what are the eigenvalues of this? Eigenvalues are 2, 2, 1 and 1. Is it fine? Now can you write the characteristics polynomial? So characteristics polynomial will be x minus 2 square, x minus 1 square. So the right answer of this problem is C is my correct answer of this problem. You can see that in this video I have written everything on the screen. But once you are in the examination, how you can solve that without writing anything on the board, on your copy. You can see. I can think about that. What is the eigenvalue of the A? 2 and 1. And it is a diagonal matrix. So what is the matrix associated with the T? Is a twice of identity. This you can write in your mind. Fine. So what are the eigenvalues of the T? 2, 2, 1, 1. So characteristics polynomial is x minus 2 whole square, x minus 1 whole square. So you can see that within a very fraction of second you can get your answers in this manner. That's why I'm asking you can follow this playlist and try to learn how I have explained you all with the help of the shortcut tricks. Don't forget to subscribe my YouTube channels and must watch about all these lectures. You can like, share and comment on these videos. Always happy learning students. Best of luck.